So this video is a continuation of our discussion about compound inequalities. The previous video, we talked about how to solve or statement inequalities. Today we're going to tackle the other type of compound inequality referred to as and statement inequalities. So these inequalities we will generally see written in one of two ways, but the reality of it is it's really only one of those ways that we will be dealing with. But I'm going to show you what at least this first example looks like when we see it using the word and joining two separate statements. So this first problem when we get working on it, I'm going to actually pull it apart and make it look more like types of or statements we saw yesterday, only swapping out the word or with the word and. But the more similar or the more recognizable way and the more common way we will see these inequalities is as a single inequality in which the variable term, in this case I mean the 2x plus 1 is the variable term, is sandwiched between two values. So you notice the variable term is sandwiched between a lower value of -3 and a higher value of +7. And it's in this format that solving an and inequality is actually a lot easier. But before we get to that, I just want you to see what this looks like if we pull it apart to make it look more like an or statement. And what's important, no matter which way we set this up and solve this, it's important for us to understand that the solution is essentially the intersection of what the two individual graphs would look like. So it's really like the overlap of those two graphs. So let's get started. So the first thing I'm going to do is to write this inequality, let's try that again, is we're going to go ahead and write this inequality right here, 2x plus 1. If I read from the middle back, 2x plus 1 is greater than -3. I'm going to write that. 2x plus 1. The mouth is opening to the 2x plus 1, so it's greater than -3. And then I'm going to write that middle expression again, but this time from the middle off to the right. So I'm going to say 2x plus 1 is less than or equal to 7. And by pulling it apart like that, we're essentially creating an and statement. So let's go ahead and quickly solve. This looks a lot like our or statements, with the only exception that when we get to finalizing our answer and graphing, we're going to have a little bit of extra work to do. So let's go back to the left side in red. Being that this will take two steps, we'll subtract 1 on both sides. And we will get 2x is greater than -4. And then we'll finish out by dividing by 2. And we will get x is greater than -2. On the right side, the blue side, you notice the steps are going to be the same. We'll first subtract 1. So 2x is less than or equal to, now careful here, the math is a little bit different. 7 minus 1 is 6. And then divide by 2. And we get x is less than or equal to 3. Now again, the only difference, and it's a significant difference in setting it up this way, is that it has the word and, not the word or. So if I wanted to graph that, what I would be doing is graphing my number line, starting at 0. Now I would have 3, and I would have 2, or -2, I should say. And if we follow each inequality, I would be putting an open dot at +2, and I would be heading to the right. Now, I'm not going to draw all the way across. And if I were graphing x is less than or equal to 3, I would do a closed dot, and I would be graphing to the left. And what's ultimately going to happen is that these two are going to merge into one single graph, and that's where the overlapping would be. So if this blue continued, it would go beyond that open dot and it wouldn't overlap with the red anymore. And if this red continued to the right, it would go beyond that closed dot at 3 and not overlap with the blue anymore. So by the time we're done, what we actually have is the equivalent of a line segment with an open dot at the -2, a closed dot at the +3, and basically just a line segment, okay? So what we're going to do is actually take this same problem and we're going to solve it a different way, and actually what I think to be the much easier way. So let's rewrite the problem. -3 is less than 2x plus 1 is less than 7. And let's begin to solve this problem. So let's see. We're first going to subtract 1 on both sides. Oh, actually, not just subtract 1 on both sides. We're going to subtract 1 to get it to cancel out in the middle. But we're going to notice that we have to do it on the left side. So we're going to subtract 1 from -3. And we're going to subtract it also from the 7 on the right side. So cancel the 1's out. Let's see. -3 minus 1 is -4. Is less than. The 2x remains as the only part of your variable expression. Is less than or equal to 6. Now notice what's happening here. This 6 we've already seen. That's the 6 that we saw right there. And this -4 we've already seen. That's the -4 that showed up in the work when we had things pulled apart. When we're ready to finish solving for x, we're going to have to divide by 2. So we can divide by 2 to get down to x. We're going to do that in the middle. We're going to do that to the left. And we're going to do that to the right. We're going to divide, I'm sorry, not by -2. There was a long pause there. We're not going to divide by -2. I was getting my signs off. We're going to divide by +2. We're going to get -4 is less than x is less than or equal to 3. Now this is the same solution as we saw back over here with things pulled apart. And I actually like it better because it kind of takes everything and puts it all back into a nice, neatly packaged final solution. And what I like further about this is that it shows that our value of x, once we set up our number line, is between a high value of 3 and a low value, whoops, not -4, again, going back and fixing my work, -4 divided by 2 is -2. And so it's between a high value of 3 and a low value of -2. And we see visually that x is between those values, which means when I graph it with the appropriate dots, an open dot at -2, a closed dot at +3, it's going to create a segment, which shows that our solutions are between those values. So this is the way that we are going to set up and solve our AND statements. So this is our preferred method. Preferred method right here. So in doing that and following that as our preferred method, we're going to do this one last time on this next problem. So we have our variable expression sandwiched between. That's evidence that this is an AND. When you get this type of structure where you have a left side, a middle, which is typically your variable expression, and a right side, sandwiched between two inequalities, we know guaranteed this is an AND. So let's get moving forward on this. So what we will do is first subtract 8 to get the variable term or start working towards isolating it. And subtract in the center, to the left, and to the right. 2 minus 8 is -6, is less than or equal to -3x is less than or equal to, let's see, 17 minus 8, that gives me 9. From here, our next step is going to be to finish solving for x. And I'm just going to do one long division line by dividing by -3. Now, the warning bells should be going off here, right? flip the signs. Oh, I'm sorry, not flip the signs, flip the symbols. We're dividing by a negative, and we already know the rule, no matter what, is going to be to flip the symbols when we multiply or divide by a negative, but this is going to be flip two symbols. So we're going to get -6 divided by -3 is 2. It's not going to say less than or equal to anymore. It's going to say greater than or equal to. Our -3's cancel, so we get x. This symbol is going to flip also. It's not going to say less than or equal to. It's going to say greater than or equal to. And 9 divided by -3 is -3. What we're further going to have to do when you look at your answer, these values are backwards. I want my low value first. So low value first. So flip the solution. So what we need to do is turn everything around. Well, conveniently, the x stays in the middle. The -3 runs to the left. The +2 runs to the right. Now what's going to happen is this symbol has to go over to be between the x and the -3. This symbol has to go between the x and the +2. And in the process, they have to turn around. So we should be, when we're done, at -3 is less than or equal to x is less than or equal to 2. And when we know we have our solution in the right order, it's because we have our low value first, our high value second. So -3 to the left, +2 to the right. Closed dot in both cases, and because x visually is in between those values in our solution, it will be in between those values when we graph. So that, again, is our final solution. So this can get a little confusing until we get a couple of these problems under our belt. So you can be sure when we come to class practicing these problems to get used to this idea, particularly turning our solutions around. So those are your two answers, and those are your two fully worked out solutions, and we'll be prepared to practice these more in class.